I want to explain to my standard level biology class why there's a problem in DNA replication because of the two strands. I have here a double-stranded DNA molecule. One strand runs from 3' to 5', the other strand runs from 5' to 3'. They are anti-parallel. In DNA replication, an enzyme called helicase unwinds and separates the two strands, breaking the weak hydrogen bonds. Once this has happened, free nucleotides, that are nucleotides found in the cytoplasm, may bond in complementary base pairs one at a time to form the new strands. This happens through the action of an enzyme called DNA polymerase. I'm DNA polymerase. DNA polymerase is limited in that it can only work in the 5' to the 3' direction. So we would like it to go from 3' to 5'. That would make it easier, okay? But actually, in this case, it only runs from 5' to 3' of the new strand, okay? So these new strands must be formed from 5' to 3'. This means that the new strands are formed in opposite directions to each other, okay? This is the root of the problem. So, as we start to form our new strands, in our respective directions, okay, helicase moves down to the DNA molecule, separating the two strands further. We see a problem forms. I want to form, on my side, a 3' at the end of my molecule, whereas on the other strand, it is simply a case of adding a new nucleotide as they become available, right where the two strands separate. Okay? This problem leaves a space on one of the strands. This strand is called the lagging strand, so called because it lags behind the other one. The lead strand simply involves continuous adding of the nucleotides. What happens on the lagging strand is some kind of catch-up process. I'm simplifying this slightly for a standard level. What basically happens, you go back to the beginning and you add them